Welcome to Netlabs Hub. In this video, I'm going to show you how to configure this project. This is a complete secure universal campus network on FortiGate Firewall in GNS3. So the first step, I'm explaining this topology. So at the end of this video, you will have mastered how to configure a complete university campus network. I have 5 FortiGate firewall. I start with this section. This is the first firewall. This is the main campus hub. It is the firewall that will manage all other firewalls in the branches. This is a university that has 4 branches in different locations within a region or within a continent. In that, the headquarters, that is the main campus, is on this FortiGate 1. This is the LAN for that particular main campus, and the main campus LAN consists of the administration, the finance department, the library, then the lecture halls, then hostels. Those are the sub-local area network within the main campus LAN. It's operating on this subnet 172.30.10.0/24. That is the reason I have given it this particular class B subnet, because there are many users on this network. So port 3 is a LAN port on the main campus. Then port 1 and port 2, those are the ports connecting to the ISP. And between the main campus being the central manager for all these branches, we do not expect for service downtime. In that regard, I'm going to configure software-defined one, that is SD-WAN Failover, between this ISP, Starlink, and Safaricom, so that when Safaricom is down, Starlink will bring up the service. Apart from that, from the main campus, I'm going to create the automatic IPSec VPN tunnels through auto discovery VPN, that is ADVPN, in that when communication happens from branch 1 to the main campus, it uses the secure VPN tunnel. Same applies to other branches. When any branch communicates with its counterpart, also it has to relay information to the main campus before it reaches the destination. So on this firewall, port 2, port 1 are connected on the ISP. Then port 3 is a LAN port. When we come to branch 1, port 2, all ports on branches, all port 2 on branch FortiGate firewall is connected to local area network to that particular branch. Like you can see, branch 1, port 2 is on the branch 1 LAN, then port 2 on branch 2 is on branch 2 LAN. Same applies to branch 3 and branch 4. Then port 1 on FortiGate, on branch FortiGate firewall, port 1 is connected to the internet, so that branch 1 is being provided the service by Liquid Telecom. You can see here. Then branch 2 is the internet provider is Jamit Telecommunication, that is JTL. Then branch 3 is being served by Airtel. Then branch 4 is being served by Seacom. So all these particular service providers are in one way or the other in coordination with the main campus hub, that is the firewall. So in general, I'm using Hub-and-Spoke VPN or Hub-and-Spoke scenario to simulate the campus network. So every FortiGate file in this particular topology is managed through port 5. Now that for port 5 to get an IP address automatically, it needs to have a dedicated cloud. But in this regard, I'm just using one cloud. You can see here, this is the cloud, then connected to an open switch here, so that every port 5 on each FortiGate firewall is connected to this switch. Then there is just one port that is connected to this particular cloud, so that all IP address will be automatically be served through this particular GNS3 server. You can see here. So all the management IP address are going to come from this particular subnet. So that's what you should understand to make to make it at least clean. I will hide this one. So I will start configuring the interfaces on the main campus firewall. I'll right click, then access the console. The moment I right click and access the console, I configure the admin account. Once I'm there, config system global, I set the host name. Main hub. Then config system interface, so that port 1 is the link facing the Safaricom. We set the mode into DHCP, set alias Safaricom 1, then set allow access ping HTTP, that is okay. Then next, edit port 2, set mode DHCP, set allow HTTP, then ping, that is okay. Set alias Starlink, set role, that is one port. So after there, next, then configure the management port 5. We set mode DHCP, then set allow. Being the management port, I have to configure the web accessibility so that I can access it using the web browser. So those are the services that you have to enable on that. Set alias MGT management, then next, edit port 3, this port, that is the LAN port. We set mode static, then set IP 172.30.10.1/24, set allow ping telnet SSH, that is okay. So once we are done on that, we save, show system interface. You can see this is the status of interface. Port 1, it has received this IP, so you can copy. Then port 2, it has received 85. Then port 5, you see it has received 75. Then port 3, that is the one port. So we can just label it, give it IP there. So the Safaricom link is operating on that. .84, then this is .85. So on this file, I'm done with the interface configuration. So I move to branch 1. Branch 1, I configure the admin account. Once I configure the admin account, we log in, username is admin, password is empty, then we enter our custom password. Once we reach there, config system global, we set the host name, that is branch 1. Then we configure the interface, edit port 2. Port 2 is connected to LAN. We set mode static, set IP 172.30.11.1/24, set allow ping HTTP SSH. We set the role to be LAN port, set alias branch 1. After there, we configure port 1 on that particular firewall to be the ISP, set mode DHCP, then set allow access HTTP telnet, then ping. Then set role, that is the 1 port, then set alias, that is liquid. So the next, we configure the management port, that is port 5. We set the mode into DHCP, then set allow ping HTTP FGM, then telnet. We allow all services. That is it. Once we do that, we are good to go. We can confirm the IP address assigned using that. You can see, so that port 1, it has received 82. This is the IP address for port 1, this port. You see, then this is for the LAN, branch 1 LAN. Then the management is not yet, you see, 76 is the management IP. 76 is the management IP, so we can access. First of all, we start by 75. 75 is the hub, then 76 is branch 1. So I'm going to have at this point, I'm done configuring the main hub, that is main campus firewall, and the branch 1. So I start the branch 2, then branch 2 and branch 3. As the firewalls are rebooting, let me configure the web accessibility for the branch 1 firewall and the main campus firewall. So you access the firewall. I don't want this firewall to log me out every time and then. So I'm going to extend my idle time, the idle time for this particular system. So you just come on the settings here, so that I stay logged in. So you just come at this point, you give it the maximum 480, then you apply. Same applies to the branch 1 firewall. we don't save, we disregard this. The moment it loads, we start evaluating our system. Then the same applies. We go to the system, then settings. Once we reach to the settings, we extend the idle time. This is 480, so that within 480, I think it will take some hours. I would have finished this particular project. So this is the main hub. Then this is the branch 1 LAN. So on the interfaces, the interface facing the LAN has to be on DHCP mode, so that this one, we just enable DHCP here. This is branch 1. We enable the DHCP on that. Then same applies to on the main campus. So on the main campus, the LAN port is port 3, you can see. Main campus LAN, then the role we specify LAN, then the DHCP here. We enable that, we give it 20, then we save. I hope at this point the branch 2 and branch 3 firewalls have finished rebooting. So it is still yet, but at this point it is finishing. So sometimes it might take time booting depending on the resources that are available. So I'm done with the main campus configuring the interfaces. Then same applies to branch 1. So I'm moving to branch 3 and branch 2. Let me check the status. The moment it gets the serial number like this one, it means that it's okay. That is branch 2, admin. We create the administrator account. Once we create administrator account, we set the host name, that is branch 2. After there, we configure system interface. We edit port 1. We set mode. This is the ISP port, DHCP. Set allow access, HTTP, telnet, and ping. Set role, that is 1. Set alias. So which ISP is providing the link to branch 2, that is JTL. Then next, edit port. So port 2 is connected to LAN. Set alias, branch 2 LAN. Set role, that is LAN. Then set mode static. Then set IP, that is 172.30.12.1/24. So once we are done, we configure port 5, that is the management. Set mode, DHCP. Set allow access. These are the services that will help us to access this FortiGate in the browser. So once we are done, then set alias MGT, then end. At this point, we use diagonalize IP address list. So this one has gotten 217. We copy that one for troubleshooting purposes. Then branch 2, we give it that way. Or we can just say .217. So this was 84, this is 85, then this is 82, this is 217. Then at this point, I want to get the IP address for the management. You see it is 77. So you copy that IP address, then you paste on the web. So this is a project that I'm doing step by step for you to understand. Once we complete this project, I'm sure you will be in position to simulate complex project. So we go to the network, then interfaces. This is the LAN port for that particular interface for this particular branch. This is branch 2. Then once we do that, we save, then we extend the idle time so that the firewall do not lock out our session. So at this point, we are good to go. So I'm configuring branch 3, admin. We create the administrator account. Always remember, administrator account is the gateway to any configuration on FortiGate firewall. System global, we set the host name. Then branch 3. Then system interface. Remember port 1 is the ISP, set mode DHCP, set allow, ping, then HTTP, then set role, that is the one port, then set alias. So port on branch 3 is provided by which ISP? That's Airtel. Once we do that, then next, edit port 2, set alias, set allow access, ping, then HTTP, that is okay. Then set mode static. We specify, because when you see I'm setting the mode of that particular interface to be static, it means I'm going to assign IP address manually. Set IP, that is 172.30.13. This is branch 3, 13.1.24. Set alias branch 3 LAN. Then set role LAN. And config system interface, edit port 5, set mode DHCP, this is the management port, set alias MGT, that is the management, set allow access HTTP, FGM, telnet, ping, then SSH. Without this, it cannot be accessed in the web. set mode DHCP. So diagonalize IP address list. So the ISP is 220, you can see. Then this is for the LAN. This is ISP. Then what about the management? The management is 78. So you come on this topology here. This is branch 3. You just take ISPs.220. Then the management is 78. You take that one. Then you just access that. So you see, this is the main hub. Then this is branch 1, branch 2, branch 3. We don't save. The first thing, we evaluate the system. We extend the idle time. Once we extend the idle time, we enable the DHCP on that particular LAN interface. This is the LAN interface. This is how we enable the DHCP. Then we specify the start IP address. Then we leave everything the way it is. So at this point, we are good to go. We go to the last branch. Imagine this is a very big campus network. This is a university that has a headquarters in one city. Then the branches are scattered across the country. And all the branches are still connected to the main campus because that is the hub for all the resources. So at this point, let me now enable this particular branch 3 is operating on this. Let's verify. We check the interface. If well configured, 13, that is okay. Then we enable this. So as branch 4 is booting, because you see I have so many FortiGate firewalls in this, to avoid overhead on resources, let me now configure the SD-WAN between the Starlink, then between the Starlink and Safaricom, so that when one fails, the other one is able to come up. So I'll access this firewall in the interface in the browser. Then to create the SD-WAN, you'll come on the network. Then under the network, there is SD-WAN here. We will start by creating a zone. SD-WAN main. We don't add interface, we just create a zone like that way. This is our zone. Then we create the members. The first member is Safaricom, is operating on this particular IP here, you can see. So we will put Safaricom. Then the gateway is dynamic, or we can specify the gateway is dynamic. So then we leave priority the way it is. Then we add another member. There is something that I have not explained to you here. So at this point, you specify your zone. So my zone is this one. The moment I include any member within the zone will be up. you see it has changed from red to green. It means now my zone is alive. It's just like a body without veins is dead. So Starlink is the second ISP. So you see, I have already created the zone. So on this, I'll create the static route. The static route, it will access any IP on the interface, on the network or on the internet, but it will pass through the SD-WAN zone. That is it. Once I do that, I'll come still on this particular. Now you can see traffic has more precedence on port 1 unlike port 2. So I'll come on the performance SLA, performance service level agreement. Then I'll create ping DNS, ping Google, so once I create that, I'm going to use the ping. Then the server, I'm going to specify the DNS for the server. So at this stage, I'm configuring the SD-WAN software-defined wide area network between the Starlink and the Safaricom, so that when one link fails, the other one comes up. You can specify another one. Then participants, we specify our participants, that is the Starlink. So Safaricom will be our link of preference, that is the primary. Then Starlink is the secondary, because you see it relies on the satellite and there is issues. You enable SLA target. We can leave this one by default. Then we click OK. So once this is the rule, but before this rule works, we have to create an SD. This is a service level agreement, but before that works, we have to create an SD-WAN rule here, so that ping can just say ping Google. Then the source is there. Where is traffic coming from? I'll create the address here, the address group, that is main campus LAN. Then the subnet, I'll just choose that one, 10.0/24. Then everything remains the way it is. So my source will be main campus LAN. Then destination, here, it will be the SD-WAN zone. So you see there is destination, there is address, then internet source. Destination is all. So when I specify all, it means it can choose any between the Starlink and the Safaricom. So then on protocols, I'll choose any. Then this one, great, I will leave it the way it is. Then manual, I'll choose the manual way. Then at this point, I'll choose the link that I prefer to be primary, that is Safaricom. Then I add the next link. So the links will negotiate in this order. Starlink will only resume when Safaricom is down, but Safaricom is the link that will always be up. Then when it comes to zone preference, I'll pick my zone here, then click OK. At this point, traffic is able to go through, but there is this section under here, firewall policy here. So I have to create a rule to enable main LAN to internet. So incoming is my main campus area network, that is LAN. Then outgoing, it is going through the SD-WAN. Then the source is all. Then destination is all. Then I will allow the service to be all. Then I'll generate sessions on start, then I'll generate logs on startup, then pick all sessions, then OK. So you see, when this link tries to try, it is in synchronization stage. So I have finished configuring the SD-WAN. So the SD-WAN is up here. We can check also if the DHCP is working. We'll just access this switch, then DHCP-D. You see, at this stage is going through the DORA process to conduct the server, which is the main FortiGate hub here. So we give it time. So we check whether we enabled DHCP on this LAN interface. This is the LAN interface. You see, DHCP was enabled. So it's okay. It's just a matter of synchronization. It will pick. IP DHCP. You see, it has picked. So at that point, the client was syncing to the server. So we can ping, that is the Google DNS. You see, we are able to ping the internet. So while pinging the internet, this is just to verify that indeed traffic is now passing through the Safaricom. Now let me suspend this link. I have stopped the Safaricom. I'm assuming that it is down. When we check, I expect traffic to continue moving. You see, traffic is still going to the internet despite Safaricom being the primary link is down. Now that it is using the Starlink. So when Starlink now also goes down, the two links are totally down. You will notice that there is total failure of traffic. Traffic cannot trace the route cannot trace the ISP to use to go to the internet. But when I enable this, link, I resume, you will see that immediately I resume, traffic will start flowing. So this is how to configure the SD-WAN failover. So the main campus hosts very critical services. That's why I have configured the SD-WAN failover to ensure that traffic between the links alternates when one is down. So in this case, SD-WAN is okay. So let me go back to finish on branch 4 firewall so that I can finish up the project through the other remaining configuration. So I'm going to create the admin account. We set the host name. Set host name, that is branch 4. Then config system interface, edit port 1. Port 1, that is the SICOM port, set mode DHCP, set alias SICOM, then set allow access ping, then HTTP. That's okay. Then SSH, then set alias. We set the role, that is the one port. Edit port. We use next, then edit port 2. Set mode DH, no static, because this is the port that is facing the LAN. Set IP 172.30.14.1/24. Then set role LAN, then set alias branch 4 LAN. So then set allow access ping telnet, ping, then telnet, then SSH. But SSH is better. So at this point, we configure the management interface. Port 5, set mode DHCP, set alias MGT, then set allow access HTTP, HTTPS, telnet, SSH, FGM, then ping. That's okay. Then we end. We verify the IP address. So you see, it has received 20. So SICOM has 20.20. So remember, this is .82.217.220.20. Then what about the management? Branch 4. We repeat the same process. The management is 79. So we pick the management 192.168.10.79. admin. So once we are at that point, we extend the idle time to ensure that we stay in our session stays, so that it cannot disturb us while configuring. This one also, you can do it in the real environment, but it is risky, especially if an intruder has accessed the firewall, will stay without being locked out. But still, you can set it. You can limit sessions. So at this point, I'll check the interfaces, then enable the DHCP on this interface. Enable DHCP on this interface. So once I do this, you can see this is the local area. This is the management port 5. That is the LAN port. What about the WAN port? The WAN port is this one. It has received this IP. So at this point now, I'm done configuring the SD-WAN, and I have shown you how to verify. You see, still traffic is going through and Starlink is down. So when I resume when I resume Starlink and suspend Safaricom, everything still will be okay. So at this point, I'm going to create the secure tunnels, the IPSec VPN tunnels between the branches and the headquarters. That's the main campus central firewall. In that, when a branch tries to communicate with the other, it uses the tunnel that is created automatically between that particular branch and the headquarters, that is the main campus. So, and also the branches, for example, on this branch 1, I'm going to configure the captive portal so that users on this particular department to access the internet or to access services within the headquarters, this is the main campus, they have to log in to be authenticated so that they verify who they are, they claim they are, while they access resources. So this is a security implementation that I have included on this particular firewall. Also, I'm going to create a high availability between these two FortiGate firewalls, between branch 1 and branch 2, so that when branch 1 is down, this one can take over, then this one can also take over. But I will show you how to do that. So, to configure the automatic tunnels between the branch and the headquarters, I will start by configuring the hub so that this one will give me the configuration keys to authenticate the branches. But this is what you have to note down, that while configuring the automatic discovery VPN on FortiGate firewall, there are factors you have to consider. That for it to be successful, ensure that the passphrase key is the same. The password that you are going to use on the FortiGate should be the same as the one that you are going to use on the branch. Ensure that you've copied the correct configuration key that is auto-generated on the hub to authenticate a respective branch. Ensure that you've also the local area network, the remote and the local area network address groups are correct. For example, if you are authenticating branch 1, then you use the local area network address group for branch 3. This particular tunnel will not be up. So what I will do, I will go to the FortiGate firewall that is serving as at the main campus. Then I'll come here on VPNs. So this type of VPN is a bit different from site-to-site VPN. This uses what we call border gateway protocol, that is BGP, to create automatic pathways, automatic policies, automatic routes to ensure that the source and destination are in coordination. So this is how I'll start. You go to VPN, then you create IPSec tunnel, then you create your new tunnel. Remember, I'm on the hub. So on this main campus VPN. So at this point, we are not going to use site to site. I'm going to use Hub-and-Spoke. So the moment I choose that this type of VPN will be using what we call auto discovery with BGP, so that border gateway protocol is the one that is going to help us create automatic routes between the the hub and the branches. So in this case, the role of this firewall is the hub. Then we choose next. At this point, incoming interface is the Safaricom interface. So in this case, let me show you something. So incoming interface, I'm going to choose the Starlink. Safaricom is an added interface, added ISP to facilitate SD-WAN. So in this case, I'm going to choose the Starlink, though it is down, so I'm going to enable it. Let me resume Starlink. So I have resumed it. So the moment I resume, then I choose Starlink. First of all, I go back, then I come back to that. Starlink is port 2. So the pre-shared key, I'm going to use that one. So at this point, you see the tunnel IPs are already generated. You click next. At this stage, you specify the local interface. If you've got more than local interfaces, you add here using this particular sign. Then spoke type is an individual, but I'm going to add how many tunnels do I have? I have how many branches? The tunnel spoke #1, it means that is branch 1, branch 2, branch 3, branch 4. So these are the IPs for my branches. So once I do that, I go to next, then I create that. You see these are configuration keys. So this is for branch 1, branch 2, branch 3, and branch 4. So you copy the key, you copy that particular key, that is for branch 1. Then you go to branch 1, you authenticate. You authenticate that particular tunnel. So this is branch 1 VPN. Then we choose hub and spoke. Then the role is spoke, not a hub. Then we paste the configuration key. Then we apply. Once we apply the configuration key, automatic pathway has been created between this branch and the HQ. That is the main campus. Then we click next. At this point, you see it has already identified the IP address, which is the 85 is the Starlink. So at this stage, we use the key that I used on the main headquarters, that is the main campus firewall. Then outgoing. So this is the incoming. So on branch 1, it has picked remote IP is 85, and then outgoing is the one interface on that particular branch, Liquid Telecom, you can see here. So then next, you see it has automatically picked the IP. Then we specify the local interface, that is the local LAN interface. Then next, we create. That's how we authenticate the spoke in coordination with the hub. So we copy the next key, that is branch 2. We do the same. So at this point, I'm creating the hub and spoke. So let me be a little bit faster, because I have shown you using branch 2 VPN. Then that is, we choose that as a spoke. Then we apply. Once we apply, next we authenticate using the passphrase key. Ensure it is the same. I'm using Fortinet. Then the local area network, we choose that particular interface for that particular branch. Then we move to branch 3. You copy the key, you go to branch 3. You create the tunnel, branch 3, VPN, branch 3 VPN, hub and spoke. The role is spoke. Then the key, you paste the key that you copied from the hub. Then you apply. Then here you use the passphrase key. You see, this is automatically generated. That is the power of border gateway protocol. The local, you pick the local interface. You see, at this point, this is down. So once I finish configuring, I'll show you whether the tunnels are up or not. So then I copy the final key, that is branch 4. Branch 4 VPN. We select the template type, that is the hub and spoke VPN, that is centered on using border gateway protocol, using the auto discovery to create the routing. So when you do site-to-site VPN, you are going to manually create the routes, but when you are using hub and spoke, it will use the auto discovery power of border gateway protocol, that's the BGP, to sync between the branch and the hub. So that's, next we choose the role as the spoke, then we apply the key. Ensure you copy the correct key. These are the requirements. When the key is wrong, there will be wrong authentication. Once you ensure that you apply, give the name, choose the template type, then next. At this point, you authenticate using the passphrase key. Remember, remote IP, it is just, so this is the pathway for the tunnel. So when I can go back here, this is 10.10.1.6. When we go to the hub, that IP is for which branch? That IP was for branch 4. Next. It is as we expect, then we finish. So once we finish this particular tunnel, I will show you how to verify that. You will go to IPSec tunnels. You can see the tunnel is up. So you see, traffic is passing through. This is branch 4 VPN to the main campus. So this particular branch in this city, for example, maybe we can say city 1, it is connected to the main campus. You see, the tunnel is up. So when we go to branch 3, then on IPSec tunnels, don't save, it's also up. You see, the gateway is the Starlink. This is the gateway for all those particular tunnels. So I have verified that the tunnel is up on branch 4, then branch 3, then now let me verify branch. Let me verify on branch 2. So you go to IPSec tunnel, also the JTL port. It is up. You see? Incoming, how many bytes? 1.28 kilobytes, then outgoing is this bluish, it means that data is going through that particular interface. And indeed, remember, at one point I shut down the Safaricom link so that traffic was going through the Starlink. So in this case, let me shut the Safaricom link so that traffic can just use the Starlink, so that if traffic uses the Starlink to access the internet, then this particular tunnel being the gateway for all these particular branches, it will show that traffic is moving through. So when I refresh here, you will see that the bytes or the traffic has increased. You can see it was 1.28, right now it is where? It's up. Same applies to here. Same applies to this point. So let me verify on branch 1. You just come on the IPSec Tunnels. You click here not to save. Then you can see. So at this point, this computer can communicate with this computer. Then this particular branch can communicate to any of this branch. So let me bring up any computer, this particular branch, just one computer for testing purposes. Just one computer for testing purposes. Piece 3. So let me user 1, branch 1. Let me just give that name so that at least we can know user 1, branch 1. First of all, we test the IP DHCP. The moment you see DORA, the DHCP functionality is working fine. So it means that that client can contact the server. So at this point, let's ping the Google. It's not going through, so let's ping the gateway. The gateway, that is 192.168.122.1. If it goes through, it means we can access Google. It's just a matter of synchronization. So what you have to do here, now check on the static routes and the firewall policy. Let me bring up this switch. So everything is up. You will come here. We start by branch 1. Let's check the routes. So let me explain something here, that you see, in terms of IPSec tunnels, they are well created. They are all up. You can see on this branch 1 is up, branch 2 is also up, branch 3, the tunnel is up and is sending traffic. Branch 4 also it's up and sending traffic. But there is just one rule that I have not created. That rule that allows the traffic from any LAN to access the internet. That rule I have not created. That's why you are seeing failures that, you see, I'm not able to access the internet because I haven't created that rule. The moment I create that rule, you will notice that traffic will just start going through. So first of all, we check the static route. I'm on branch 1. So we refresh, then you see there is no static route. When we check on the firewall policies, I'm sure they are there for the VPNs. You see, branch 1 VPN to this, to this. So at this point, I'm going to create the static route. The static route is anything on the internet, then the interface, the gateway, it will be there. So this rule, the static route is going to pass through the VPN. We can choose, for example, here, this is what I'm trying to mean. Static route is going to define the path through which traffic flows, so that when this computer tries to access the internet, we can allow it to go through direct, or we can allow it to use the tunnel that has been created here, so that the moment traffic comes this way, goes through this switch, reaches this particular firewall, it will not choose this particular port or interface or a path. It will choose the automatic tunnel that has been created between this branch and that branch and the hub, that is the main campus. So in this regard, we can create this one so that it can pass through branch 1. You see, so traffic to access the internet, it will pass through any destination, but the interface will use that one. We can now create that one also. There is no need to use that. You see, the moment I create that one, the one with the tunnel is given preference, so that when you are pinging the internet and the tunnel, security is preferred here. So traffic tends to go through the IPSec tunnel that was created, unlike the internet. So once we do this, I create here a rule so that branch 1 LAN to internet, so that the source is that one. Then outgoing traffic is going through that particular port. We can create 2, use that, then the source, is all. So on this, we select all session. If it is using this, we disable NAT. You see? So this is branch LAN to the internet. Remember here NAT was disabled. So let me just show you something. So here when we choose Liquid Telecom, then enable NAT. Let's see how traffic is how it is behaving. So you see, initially I tried to access this particular gateway for the internet. It refused to pass the traffic, but the moment I have created the static route and the rule, we've been in position to access the internet. Now I'm sure when we try to ping Google now, it is going through. You see, it's going through ping google.com. You see, it's working perfect. So that's how you can do the same on this branch too. Let me go a bit faster. So on this, you will just choose that JTL interface, then dynamic, that is the first interface, then the first static route, then the second, we'll use the VPN, then it's okay. we create the rule. The first rule, branch to LAN to ISP, that is the internet. Incoming is the LAN port, outgoing is the JTL, then source is all, source is everything, then the service is everything. NAT is enabled. We do that, we generate logs on startup, we finish. You see, it is trying to synchronize. Same applies to branch 3. We create the route, static route. This is define how traffic is moving. We start with that one, so that when traffic is going through the IPSec tunnel, it will choose this kind of static route. When it chooses to go through direct to the internet, it will use that particular static route. You see, the one that uses the internet is given preference. Same applies here. If traffic is going through the internet, it will use this particular policy. So the source is the LAN, then the destination is the outgoing is Airtel. This is what I mean. So we are on this particular port. So this is the incoming, then this particular port is the outgoing. So then everything is all, then all. At this point, all sessions, we generate logs on startup, then OK. This is LAN to VPN. So when we want to branch 3 LAN to access the VPN outgoing, it will use the VPN, then the source, it will be all, or you can create the address group if you want it, or still that one can work. Then the service is everything, but you disable NAT on that. Then you generate all sessions the same. So that's what you do. You create 2 firewall policies. Also, you create the 2 static routes, one for the VPN and one for the automatic access to the internet. Same applies to this. Branch 4, static route. So we start by that of VPN. We choose that. This is the VPN tunnel. It means that any address on the internet, any address, but if you want to access any address here, this is the interface that you have to go through. Then the second, we'll just repeat the same, but at this point we will choose the CCOM, the 1 port. The gateway is dynamic. We come on the firewall policy. We start by creating that one to access the branch 4 to internet. So if you want to access the internet direct, ensure that NAT is enabled. Then outgoing is CCOM. Incoming is the local area network interface. Then the source is everything. It means that entire IPs on that particular source address. Then at this point, because this one we are accessing the internet, we are not going to disable the NAT. Then OK. So the next rule, this is branch 4 to main campus VPN. So incoming still is the LAN port, then outgoing I'm going to choose the VPN tunnel, then the source is everything, then the service is also everything. Then on this I'm going to disable NAT. NAT is not needed because it's not going through the internet for translation. Then OK. You see, the moment it blinks this way, it is synchronizing. So let's check on the logs. I'm trying to communicate from branch 1 up to branch 4. So let me pick a computer on branch 4, this computer here. Let it get IP address. It is 403. So you see, Dora, it has received 14.2172.30.14.20. Then what about this one? It received which IP? Let me check. 11.20. So ping 172. Let me just reload this particular computer, then make it at least large for you to see. I'll give it 13. 13 is okay. 13 is okay. And then once I give it that way, you see the address. This is its address. So I'm pinging the destination 172.30.14.20. You see, I'm on user 1 branch 1, but I'm pinging from this computer to this computer. So traffic is using this particular tunnel. Traffic is going to the main campus to be decided where to go through the tunnel. So this branch can comfortably communicate securely through the automatic IPSec tunnel that was created between that particular branch and the main campus. If I try to capture the packet at this point, because this is the outgoing, you will see the IP address for, let me just cancel this. I want to show you how to capture packets. Start capture. So when I start capturing packets here, you will understand this is the IP. You will see these IPs, two IPs, 172.30.14.20 and 172.30.11.20. So while this is ongoing, the interface is loading. Traffic is in continuous mode. It's pinging continuously. So you see, remind me later. You can see there is much that is passing through that particular interface. So let me stop some of the traffic. So let me stop this. Then also stop this one. So let me just have that one only, then see what is happening. You see, the source and destination it is passing through, it is interchanging between .20. Let me just post something here. Stop. You see, at this point, we've got .20, then .82. Let's go back to our topology. .82 is the liquid telecom, the ISP link that is connected to branch 1. Then .20, this is the SICOM. So the source here, it's liquid telecom, then destination is SICOM, you see? The moment I tried, so traffic is coming from the LAN that is connected to liquid telecom or branch 1 LAN to the internet, but destination is branch 4 user, you see? So that's how it is moving. When I try to capture this particular interface now, let me see the difference. Then I stop this one. We quit that. You see? Now you can see the IP address for the particulars. We've got 30.11.20. This is the IP address of the computer connected to branch 1 LAN. Then this is the IP address for the computer that is connected to branch 4. So I have shown you that indeed communication can happen between any branch here, irrespective there is no direct connection. So the remaining thing, I'm going to configure the high availability so that when one branch is down, the other one will bring it up. So I'm going just to select any 2 ports between these 2 firewalls. So in my case, port 6 and 7 are going to be the heartbeat interface. So 6 connects to 6, then 7 connects to 7. You see? This is high availability. So we can just duplicate this. So this is IPSec tunnels. Then when we come at this point, we edit this. This is high availability in active passive mode. High availability in passive active mode. So this is it. So 2 interfaces here, they are heartbeat. So I will go to branch 1. Then I'll go to the network. That is the SD-WAN. So I'll go to the system, then choose high availability. Then choose the mode, active, passive. So this, I'm going to give it 240 as the priority. The higher the priority, the higher the chances the firewall to serve as the primary. So the group name is Netlabs Hub that way. Then the password we can change to be Fortinet. Let it just remain Netlabs. So at this point, the monitoring interface is the LAN port, then the WAN port. Those are the monitoring interface. Then my heartbeat interfaces are port 6 and port 7. So management interface reservation, I'm going to reserve that particular management. So destination subnet, that is 192.168.10.1, that's the gateway. So that in this case, my management IP is not going to be overwritten. So branch 1 is going to serve as the primary. The moment I save, it will reboot. So let me enable the same to branch 2. Let me do a big, we can leave it default that way. Then the cluster name is Netlabs Hub. Then the password is Netlabs. Then the monitoring interface is the WAN port and the LAN port. When it comes to heartbeat interface, these are the synchronizing interfaces, port 6 and port 7. So on this, I'm reserving my management. The management port is port 5. Then the gateway remains the same. Then the IP is 77. So once we do that, we can just reboot branch 1 and branch 2. This is branch 2. Execute, reboot. So we are rebooting branch 2. Let me reboot also branch 1. This is branch 4, so I do not need branch 4. Execute, reboot. So as the two branches reboot, let's verify some of the features, some of the verifications on this particular firewalls as IPSec tunnels is concerned. So when we go to events, then we can check, this is branch 3. We go to VPN events. Then you will see the events here. You see how the tunnels have been negotiating, you see, and this is the tunnel statistics. So when one is down, you will get the information here. Same applies to branch 4. You go to the logs and reports, then you go to events. You check the VPN events. You see, this is branch 4. So when we go to the hub, on the hub we will check two issues here. We will check events. First of all, VPN events. You see, this one failed because it means two branches failed. Like this one, the way it was reporting, it was down. Then branch 2, you see, it's reporting. So this particular notification has been synchronized into the hub. So at this stage, we can also check the SD-WAN events. We can check the SD-WAN events. Now see, the service will be redirected in the sequence order. So this is what I mean. When this is down, then service will have to choose the Starlink path. When this one is up and this one, when this one is down, then Safaricom is up, it will go through the primary link. So this is the order through which this particular firewall is using. When in the order according to the SD-WAN rule that I created, and also the preference that I gave these particular two links. So you see, so these are the logs that were generated the time I was suspending, testing the SD-WAN, whether it is working, the failover is working. So on the aspect of IPSec VPN, I have successfully configured the automatic tunnels between the main campus here and every branch here. So on this particular firewall, now that branch 1 and branch 2 is syncing, I'm going to configure the captive portal. For example, so I'm going to configure captive portal on this interface, user 4, so that when this user accesses the internet, he has to log in. So I'm going to pick to connect this. So captive portal, I'm configuring captive portal on branch 4 and branch 1. So I will start by branch 4. So I will enable this computer. So once it is enabled, I'll access the console. First of all, let me stop the packet capture to ensure that at least I do not have overhead of resources. So at this point, I'll access the terminal. I'll access the terminal to know whether it has received IP address automatic or not. IP add. You see it has received this IP address. Let's just go back. 172.30.14.21 because it is in the branch 4. When we try to ping the internet, are we able to ping the internet? Let me check where the issue is. It's just a matter of time it will accept. IP add. Let's ping 192.168.122.1. You see it's pinging. So let's check how I configured access to the internet on branch 4. So I'll check the policies and objects. Internet, so the rule is there. Then that one for the VPN is there. So for you to know that the rule is being in use, you see the buckets here. So on this, execute ping 172.30.10.20. I'm pinging branch 4 is communicating with the main campus. The moment it has sent that particular traffic, you will notice that the tunnel traffic has increased. You come on the VPN. You see, traffic has increased. So in this case, let me check. We will access this particular computer and then try to access the FortiGate firewall. If we are able to access the internet, then we'll know what to do. There is a session failure bit. So to configure the captive portal on that, first of all, you come on the security profile. You come on security profile. You choose a specific service to be accessed. So in this case is application control. I'm creating the application control so that when you are on branch 4, you cannot block social media. So I'm going to block all social media here, all social media platforms. I'm going to block them. So I'll block that one. I'll enable the gaming also. I'm going to block it. Video and audio, I'm also going to block it. Then click OK. So this is the rule that I have created. You see? This is the rule that I have created. So this rule, I'm going to apply it on that particular firewall policy. First of all, you come on the LAN interface. This interface. At this point, you enable the security profile. Security mode, you enable security mode. On security mode, choose captive portal. So authentication is going to be locally. Then users restricted to a group. Then you choose a group. So I'm going to create a group and a user on this firewall. So first of all, I will choose the group, branch 4 users. Then I have no members. Next, I create a user. VR4. Then password, Fortinet. Password is Netlabs. No two-factor authentication, then submit. On this user group, I'll come on the user group, then add the member who is branch 4, then OK. So that when I come on this LAN interface, I restrict that users on this particular LAN have to log in to ensure that they access the service. So I enable security mode, then captive portal restricted to a certain group, choose the group that I have created, then you specify the URL. For example, facebook.com. So if you have to access facebook.com, you have to do what? To be authenticated. So I'll just come on the security profile and delete that particular rule that I have created. I'll delete this one because I'll not apply it. So steps to create captive portal. First of all, you create a group, you create a user or users, then you create a group. You join the users into the groups. Once you join users into the groups, then on the interface that is facing the LAN, now you enable the security mode. You restrict this group to authenticate through captive portal locally on that particular firewall by choosing the group and also restricting access to that group. So once you do that, to access the internet, those users have to log in. Let's check if at this point this PC can access the internet. Ping. So there is an issue to do with access to the internet here. So let me enable that. So I'll branch 4, I'll come on this particular firewall policy, then check this rule. So incoming, that is branch 4, outgoing, that one. Everything is okay, NAT is enabled. Then there is this one. So incoming is that one, then we choose the outgoing. The source is all, we disable NAT. That's okay. So on this particular computer, we have to access the internet. 192.168.122.1. Let me check what happened. So you see at this point, just to verify the high availability, so that branch 2 is now serving as the secondary, then branch 1 is serving as the primary, and they have synchronized. The essence, I retain the management at this point. They cannot override my management. To check that, you can just come on the system. You see, traffic is going through. So that's how you can enable high availability, so that when one is down, then the other one has to pass traffic. So thank you so much for following throughout this particular complex project, building a complete secure university campus network on FortiGate firewall using high availability in active mode between branches, encompassing captive portal, also using the SD-WAN failover between the headquarter internet service providers, and using the automatic discovery VPN or Hub-and-Spoke VPN So I have compiled this particular knowledge into one complex project, even though it has taken time, but if you follow along, you can learn all these features at once. So don't forget to subscribe to Netlabs Hub on YouTube for more tutorials. If you maybe if you follow and maybe fail to get what I have achieved, please feel free to contact so that we can help each other to grow. Thank you so much.